Hello, middle school math students. This is your lesson on the math practices. Today we're going to cover math practices 1 through 4. To get started, we've got our warm-up, my favorite now. The directions are on the screen. If you're doing this at home, you're just going to do this on your own sheet of scratch paper. Let me scroll down. Here is your balance mobile or balance puzzle that you'll be solving. Pause the recording until you have your solution. Okay, students have finished and turned in their warm-up, so here is the next stage. Here is my favorite no. To begin, as you're looking at my favorite no, will you identify at your tables, talk about what are some things that were done very well? What are some things that you like seeing? Talk at your tables, ready, set, go. Okay, and now come back to me and let's share with the class. What are some things that this student did very well? Hannah. Say that again. Yeah, the model's good. How are we going to show our work if we don't even draw the model, right? So they drew a great model. They put the same problem on their paper so they could work through it. What else do you like? Bethany. The total, yeah. Words are hard sometimes, right? We forget that word. Yeah, they again included some of the information that was given in the problem, knowing that the total is 14. Any other things that you like? Xander. Yeah, great. They split the 14 into two groups of 7 because it's balanced, and so we can see a 7 and a 7, and that's written really small, so that's really impressive that you were able to zero in on that and find that. Great job. And is that Kylia? Kylia. Yeah. Great. Yeah, I like that too. They put like this bracket or this brace around these saying, hey, these are all the same. We have 3 of the same thing. Helps us to recognize it. Okay, now let's talk about mistakes. Or what went wrong here. Go ahead and talk at your tables and let's see. If this person were sitting at your table, what would you say to them? Okay, and what advice would you have to or what would you say to this student if they were sitting at your table? Braden. Yeah. I think part of it is not just that they forgot the answers. I think that there is one critical piece of information that's missing. What is that critical piece of information that they missed out on? Ryan? Yeah. The heart. Yep, it's okay. The heart is equal to 5. And they missed that in their problem. And that tells me it's not that they don't know how to do this problem. They didn't leave it blank because they don't know. Obviously, they have some really good things going on here. They left it blank because they missed a certain piece of information, right? And that piece of information is that the heart is equal to 5. All right, let's finish up this problem with the student. What else would we tell them now that we remember from the original problem that the heart is equal to 5? Sage is a new hand. Yeah, exactly. So it comes back to understanding what the student already did, that this 14 is the total, but it's split evenly into a 7 and a 7. And so, let me turn off this autofocus. I think that'll do the trick. Knowing that the heart is 5 and this whole branch here has to be 7, then that leaves us with these have to be a 1. So the moon, the crescent moon, what does it have to be a 1? Next step, what would you do? Xander? Yep. Perfect. So again, we take what we know from this side. We know that the crescent moon is now 1. We know that this side is 7. And if I take this 1 away from 7, then that means that what is left has to be equal to 6. And again, that's where that brace that we saw was done really well is really helpful. So those 3 squares are 6, which means each one of those squares would have to have the value of 2. I still see some hands. What are your questions or comments, Bethany? Yeah. Mm-hmm. Yep, so we can see that there were some erase marks. They had some more attempts below that. Okay, that is it for our My Favorite No. We are going to move on to our math practices. So to begin, I want you already have this paper in front of you. I want you to make a circle map. Well, fill in the circle map. How do good mathematicians do math? Have there been times when you have felt like you were an excellent mathematician? What were you doing when you felt that way? Have you ever seen someone who really impresses you with their math skills and their math knowledge? What were they doing? So I want you to take just 60 seconds, and I want you to fill in the circle map with as many qualities, characteristics, and behaviors. How do good mathematicians do math? What do they do? I'm going to pause the recording as we do this. So at home, pause as you fill in your own circle map. Pause the recording now. All right, now it's your turn to call out. What are some things that good mathematicians do? I think to make this go a little bit faster, I'm going to have you guys just call out instead of me calling on names. So call out. I'll repeat it back once I've heard it, but then will you guys wait to call out something new until I'm most of the way done writing? Each time you hear something, if it's really good, then will you add it to your own circle map? Okay, get started. Shows work. I heard good things, but you have to wait until I'm finished writing. Shows work. Okay, now the next one I heard was makes mistakes. I love that. Good mathematicians are definitely going to be making mistakes. Share ideas. Yeah, read instructions carefully. Yeah, growth mindset. Trial and error. Yeah, for sure. We don't always know exactly what we're doing, right? Sometimes we just gotta try something and see if it works. Can you put that in your own words? I know what you're trying to do. Put it in your own words and then I'll write it down. Able to explain. Focused, is that what I heard? Ready. Confident. Part of that growth mindset, right? What else? Asks questions. Great. Values others' ideas. Uses models. Yeah, makes mistakes. Learns from mistakes. Organized. Are there any others? Mine's getting pretty full, but if there's any others, I'll take them. Works hard. I'm sorry? Understand the problem. Perseverance. Never give up. Okay. Now for my 8th graders seeing this right now, then you have done something similar. So this is no surprise that a lot of these things you're going to be seeing in these math practices. And that's why a lot of the things that you called out, you're like, hey, I know that perseverance is part of this. I know that critiquing the reasoning of others is part of this. And so that is the introduction to the math practices. The standards for mathematical practice are how good mathematicians do math. These are the habits that math teachers strive to develop in their students, and students become mathematically proficient in engaging with the mathematical content and concepts as they learn, experience, and apply these skills and attitudes. So it is completely and totally possible for you to apply these skills and attitudes, and when you're doing that, you are, one, becoming a better mathematician, but you're following the math practices. So I'm going to go through the first 4 today. I have this document that is mostly filled out. There's not going to be a ton of writing. We're going to write down a few examples. I'm going to ask you to put some stuff into your own words. So what I'm going to do now is I'm going to read standard for math practice 1 is make sense of problems and persevere in solving them. This is kind of a description of what that means. So I'm going to ask you, will you pause the recording, read through that description, and students are going to read that together in class and discuss what they think it means. We're going to pause the recording now. Okay. We have discussed in class, so now it's time to come back together. What do you think this means? Try and put it in your own words. Let's start with Adia. Yeah, there's 2 parts there, right? We need to do first our part to make sense of problems. We need to continue even if it's hard, but then we also need to know it well enough that we can explain it to somebody else. What other thoughts or comments do you have regarding this? Gunnar? Yeah, good to look at multiple angles of the problem, seeing it from different perspectives, trying it in different ways, making connections between those different ways. Any other thoughts? All right, you can put this in your own words, but I found a mathematician blog recently, Robert Kaplinski, who helped put these in more student-friendly language, and so I really like what he had to say for a lot of them, and what he says here is make sense of mathematics. That's it, simply. He didn't say anything about perseverance. So I'm adding the part, I think the perseverance part is one of the most important things with this math practice. And it really, really highlights growth mindset. And so I would also like to add, believe in yourself. And persevere when it's challenging. So we understand what this means, but I think making sense of mathematics, making sense of problems is sometimes easier said than done. So let's leave with some tools in our toolbox. Let's leave with some ideas. How can you make sense of problems? I'm going to go a quick discussion at tables. I'm not going to pause the recording this time. What are some ways that you can make sense of problems? What can you do? Ready, set, go. All right, and what are some ideas that you have that you'd like to share now? I have 3 bullet points. I'll not maybe list everything that is said, but I will list some ones that I really like that are said. Swede. Yeah, rereading it, really reading it carefully. Adia. Yeah. So what I'm going to say there is, yes, it's comparing your model with others, but sometimes maybe you don't even have a model yet. So finding different ways to represent the problem. So we can always find different ways, whether it's different ways that you yourself have done, comparing your models to other models of your own, but finding multiple models or ways to do the problem. What else can we do? Ryan. Yeah, so that's focusing on that perseverance aspect for sure. But how can we make sense of problems? I would like to offer one of my favorite problem-solving strategies, like specifically to story problems, right? Susan walked to the store 3 blocks east, and like all of that kind of stuff. It can be really sort of muddied in all of the words. So just stop and just visualize what's happening. Think of it like a story. Think of it as a story first and then worry about the math. Don't worry about the problem part, worry about the story part first. All right, that's it for Math Practice 1. Let us move on now to Math Practice 2. Math Practice 2 has always been one of my favorite ones to present. I have another video just on Math Practice 2, but since we're doing this really short and sweet, Math Practice 2 is reason abstractly and quantitatively. It says to make sense of the quantities meaning like numbers and variables, and their relationships in problem situations. Translate between the context. I'm going to use that word context a lot, but context just refers to the story, the real life part of the problem. So translate between the context and the mathematical representations. This includes the ability to read a story problem, write an algebraic expression or equation for it, solve or simplify or do something with that algebra or with that math, and then go back to the original situation. When you solve it and you get W is equal to 8, what does that actually mean? 8 what? Tie it back into the story. And so what I like right here, this is again from the math blogger Robert Kaplinski. He writes, when we reason abstractly and quantitatively, that means we look at problems in different ways. But specifically, it's not just using different models. The different ways that we're looking at them is by adding or removing the context. So adding or removing the story part to solve problems. For my example, I always go back to, I could say the width of a rectangle is 6 inches longer than its height. Its height is 11. What is the width? And you're already lost in all of that, aren't you? So there is a real reason why we might need to answer that question. That's our quantitative. But sometimes, isn't it just easier to think about the problem this way? Could you solve that problem? Yeah. Does it take very much brain power to solve that problem? You probably, honestly, you probably don't even need to do any algebra. You're just like, well, obviously, that W would have to be equal to 5. That's the beauty of abstract. Sometimes when I remove the mess of the situation and just look at the math, we can do the problems very quickly. But if I have to focus on all of the words, the width of a rectangle is 6 inches, or I'm saying that wrong, aren't I? The length of a rectangle, see, that's why. The length of a rectangle is 6 inches more than its width. And the length is 11 inches. Wow, what a mess, right? But when we really just break it down, it doesn't have to be that scary. This is our abstract version. But then, when we reason abstractly and quantitatively, here I started with the context. I represented it abstractly. I was able to figure out that W is equal to 5, and then I asked myself again, wait, what does that mean? What does that actually represent? We go back to the story, and we understand that that means that the paper is, or the rectangle is, 5 inches wide. That's what reason abstractly and quantitative looks like. Math practice 3 is one of my favorites. It is something that we just did this morning for our warm-up. It is construct viable arguments and critique the reasoning of others. We're a little bit short. No, we're not short on time. So I'm actually going to have you pause the recording and read through the description. You're going to write and discuss with your table, what does that actually mean? There's 2 steps, 2 parts to this one. What are each of those parts meaning? So we're going to pause the recording now as you discuss as a table. Ready, set, go. All right, what does this mean? Math practice 3, construct viable arguments and critique the reasoning of others. How can we put it into our own words? What are we really saying here? Jason. Go ahead and answer anyway. What does it mean to critique the reasoning of others? You're the one who called that out during the circle map. So what does that mean to critique the reasoning of others? Yeah, question their answers and make them prove it. Exactly. What does it mean to construct your own viable arguments? Ryan. Make a, reasonable counterclaim. Or even if it's not a counterclaim, just a claim to begin with, right? You can always counter it later on. So the math wording that Robert Kaplinski used, he says, explain and defend your reasoning. I also think it's really important that we try to understand how others think about problems. When we can understand how others think about problems, whether it's correct or incorrect, it's always going to deepen our own understanding. So now once again, I'm going to ask you, go back to your groups. This says I can construct viable arguments by how? How are you going to construct your own viable arguments? How are you going to be able to explain and defend your reasoning? There's 2 bullet points, so I want you to come up as a table with at least 2. And I can critique the reasoning of others by, what can you do to critique the reasoning of others? What are the steps that are even needed for that? So again, talk at your tables. We're going to pause the recording again as they prepare to fill in these next bullet points. How can you construct viable arguments? What does that look like? Oh, I'm so happy to see this many hands. Let's go, Lexi. Yeah, that's the main thing, right? Show your work. If you show your work, you're halfway there. Any other ways that you can construct viable arguments? Landon. Explain your thoughts, because sometimes there's a problem where maybe you don't actually need to show step by step what happened, but still explaining your thoughts, whether it's writing a sentence or verbally. Great. I can critique the reasoning of others by, how can we do the opposite of that then? How can we critique the reasoning of others? Daxton? What if they didn't do anything wrong? Yeah. So I think that part of critiquing the reasoning of others, it's not always a negative thing. It's not always finding a mistake, right? Sometimes it's finding all the things that they also did well and how they thought about the problem. Let's go, Austin. Yeah, explaining how to improve. But again, we're assuming that all the time the people are going to be wrong, right? What if we can learn from them? So I want to focus on critique the reasoning of others could also be a positive thing. And I would like to offer a tip. The number one thing to critique the reasoning of others is you first have to listen, right? You have to listen to what their reasoning is. Listen with an open mind. Because if you're really listening, What if you're the one who's wrong and you can learn from that? But you would never be able to do that if you're not listening. So I like listening as the first thing, and then after we listen, then learn or help them learn. All right. That's great. Math practice 4. This one's going to be short and sweet. Model with mathematics. Apply mathematics to solve problems arising in everyday life, society, and the workplace. Identify important quantities and create a mathematical model like equation, graph, table, picture, symbols, etc. And interpret mathematical results in the context of the situation and decide on whether the results make sense and improve the model if it does not. So there are two parts to this one. I've always taught it as just one way, but I think that there's actually two ways to interpret this. Model with mathematics. Ask and answer questions about the world using math. The whole thing is we're supposed to be modeling the things that we see with math. So ask and answer questions about the world using math. But I also think that that word model gives us some really great ideas to help us with Math Practice 1 and Math Practice 3. Can we use models to help us understand or to explain our reasoning to somebody else? And so I think that there's a second part here that we don't always talk about. Use multiple models to see the problem in new ways. So now we have enough time. I want to pause the recording once again. During this pause, I want you to take another 60 seconds talking with your groups. There are 6 bullet points. How many different math models can you come up with? How many different ways can we represent problems? So we're going to pause the recording as you discuss with your groups, trying to fill in as many of these bullet points as you can. Ready, set, go. All right, give me some math models. Bethany. Equations, yes. Very abstract, right? Going back to Math Practice 2. Equations. I haven't heard yet from Caitlin S. Sorry? Tables, yes. We did a lot of that last year. Tables, T-charts. Eli. Graph, yes. Lots of that this year. We'll be doing lots with graphs. Sage. What kind of diagrams? Okay, diagrams that show work, that show the steps, like a flow chart or something like that. I think I've called on every hand at least once. Let's go, Swede. Arrays, yeah, going back to some old models from back in the day, right? Arrays. Hannah. Sorry? Dot plots, going to statistics, I see. Yeah, dot plots, which then could open up things to histograms. Bar graphs. This has not been said yet. Let's see what 80 has to say, and then I'll add one more. Yes, thank you, pictures. Sometimes, as I mentioned in Making Sense of Problems, we visualize what's happening. Sometimes we can then turn that into a picture. Draw a picture of what's happening. It'll help us understand. Bethany. Pie charts. More with statistics. See, it was easy to come up with 6. You guys are coming up with way more. Hannah. That's like a histogram, bar graph. I mentioned it, I didn't write it down. And Ryan. Spreadsheets. I love that nerdiness. Spreadsheets, yes. Okay, love it. That is it for your lesson on math practices 1 through 4. We're going to continue this lesson tomorrow with 5 through 8. Please be sure to go into Canvas and make sure you complete math practices 1 through 4 assignment.